Hi, I'm Shannon Seaver. Today we are looking at section 6.3, and this is all applications of linear equations. Specifically, we are looking at story problems to solve that are in linear equations that we need to solve. So here are some strategies for solving word problems. First of all, you need to read the problem carefully at least twice probably, and attempt to state the problem in your own words and state what the problem is looking for. If it's not in your book and it's on a piece of paper, you can highlight things that are important to you. I really recommend doing that. Let x or any variable represent one of the quantities in the problem. Step 2 is, if necessary, write the expressions for any other unknown quantities in the problem in terms of x. 3, write the equation in x that models the verbal conditions of the problem. And 4, solve the equation that answers the problem's question. Last of all, check the solution in the original wording of the problem, not in the equation obtained from the words. In other words, look to see if it's logical, if your solution makes sense. Because sometimes we do things and it mathematically looks okay, but then if you look back at the word problem, it makes no sense what our solution was. So you need to check that. So here's our first word problem that we're going to explore. 4 subtracted from 6 times a number is 92. So we need to pay attention to certain things. First of all, is telling us that there's an equal sign there. So I'm going to have my equal sign right here, and I'm going to have 92 on the right. But on the left side, we need to worry about 4 subtracted from 6 times a number. Well, since it's being subtracted from something, I'm going to say minus 4. 6 times a number, we don't know what that number is. I'm going to call that n. You can call it x, you can call it y, it doesn't matter, but you can call it whatever you want. So it'll be 6 times n. Minus 4 equals 92. So now we need to solve for n, and we can do that by isolating n and getting everything away from it on the left side of the equation. The first thing we should get rid of is this minus 4. And since it's minus, we're going to do the opposite and add it to both sides. So 92 plus 4 is 96. And then we still have 6n over here. Now what we're going to need to do is divide everything by 6. So 6 goes into 9 once. And then we do long division here. Then we have 6, and we have subtracting, we have 36 left. So 6 goes into 36 16 times. So we can say that n is 16. Now, does this solution make sense? Let's try it and see if it actually works, and then we can say, yes, this is the right solution. So 6 times 16 minus 4 equals 92. Well, 6 times 16 is 96 minus 4, and indeed 92 does equal 92. So this is the correct solution. Let's try another problem. In 2004, Americans purchased 40.7 million gallons of organic milk, increasing at a rate of 5.6 gallons per year. If this trend continues, when will Americans purchase 79.9 million gallons of milk? So what we need to do, first of all, is write down some important information. We know that they purchased this many gallons in this year. And we also noticed that there was a rate, a change of something. So we saw that there's a rate, and there's also this word per. Whenever you see per, you know that there's going to probably be some kind of variable attached to the number that's associated with that. So we have 5.6 million gallons per year. So it looks like that we're looking at a variable of years. If this trend continues, when will Americans purchase 79 million gallons of milk, organic milk? So first of all, we need to set up our equation. We know that in 2004, 40 39.7 million gallons were purchased, and I'm just going to have that on the left side of the equation. And the rate of it is increasing at 5.6 million gallons per year. So if this is what we started with in 2004, we're adding to that number 5.6 times, I'm going to say Y for years, and they're wondering when it will actually be 79.9 million gallons. So what we're going to do is solve for Y here. Subtract 40.7 from both sides. So we have 5.6y equals 39.2. So if we use a calculator to calculate this, we will find an answer of 7. So y is actually equal to 7 because we divided both sides by 5.6. And y is 7. Now, we started in 2004. So if we're adding 7 years to 2004, what year will it be? So we're going to do 2004 plus 7. So that means in 2011, Americans will be purchasing 79.9 million gallons of milk. We can go back and check to see if 7 is indeed the right answer by plugging it into the to y. So 40.7 plus 5.6 times 7. 5.6 times 7 is 39.2. Adding that together, we do indeed get 79.9. So this looks like it's correct. Now let's logically think about this. Does it seem like in 7 years that seems like a logical answer? Well, think about it. It's increasing by 5.6 million gallons per year, and we're only wanting a difference of about almost 40 years. So 5 goes into 40 about 8 times. Well, so this was a little bit less than 8, but it still makes logical sense. So this looks like this is a good answer. Let's try word problem 3. In 2004, the number of injuries from basketball exceeded those from football by 0.6 million. The number of injuries from bicycling exceeded those from football by 0.3 million. Combined, basketball, bicycling, and football accounted for 3.9 million injuries. Determine the number of medically treated injuries from each of these recreational activities in 2004. So, let's go back and highlight the things that are important to us right now. We know that basketball exceeded football by 0.6 million. I can write that out in numbers by saying basketball equals football plus 0.6. Let's do the next sentence. The number of injuries from bicycling exceeded those from football by 0.3 million. I'm going to go back and change my basketball to BB for basketball, and I'm just going to have BK for biking. We know that biking exceeded football by 0.3 million. So that was added to the number of football injuries. So the last thing that we want to look at is it says combined. Combined means we're adding all of these things together. So combined, basketball, bicycling, and football accounted for this many injuries. So let's write that out in math. We know that basketball, biking, plus football accounted for 3.9 million injuries. Now, we want to determine the number of injuries from each of these activities. Problem is, we have quite a few equations here. But what we can do is change these two variables into what they were above. By making this whole equation f, we can solve for f. So I'm going to substitute this in for here and this in for this. So let's do that. F plus 0.6 plus F plus 0.3 plus F equals 3.9. So we have 1, 2, 3 F's over here. I'm going to add those together. And then 0.6 plus 0.3 is 0.9. So now we need to solve for F. I'm going to subtract 0.9 from both sides. And if I do that, I have 3F equals 3. So F, if I divide both sides by 3, is 1. So in the year of 2004, we had 1 football injury. And remember, we're talking about millions. So there's 1 million football injuries. Okay? And if I plug that back in for basketball, I know that we have 1 plus 0.6, or 1.6 million injuries for basketball. And for biking, if I plug that in, it's 1 plus 0.3, which is 1.3. And this is for biking. This is for basketball. So now if I said there was only 1.3 injuries, that wouldn't be right, because you can't have 0.3 of an injury. But we got to remember we're talking about millions. So this seems pretty accurate. We can go back and check our work, but this is a good problem and we've got a good answer here. Okay, so let's look at our last problem for today. We're choosing between 2 long-distance telephone plans. Plan A has a monthly fee of $15 with a charge of 0.08, and look at that, we have a word per minute. So that means we are attaching that 0.08 to a variable of minutes. Okay, so let's look at Plan B. We have a monthly fee of $3 with a charge of 0.2 per. Looks like minutes is our variable. So let's write this out. Plan A equals 15 plus 0.08 M. Plan B is $3 plus 0.12 M. We want to know when will the plans be the same. So we want to make Plan A equal to Plan B. So what I'm going to do is take these two equations, set them equal to each other. 15 plus 0.08 M equals 3 plus 0.12 M. And we need to solve for M. And they're on both sides of the equation, so we need to move one of them over. Let's move this 0.8. 0.08 M on both sides. And we can move this constant of 3 over the other side by subtracting it from both sides. So this cancels, and this cancels. So 15 minus 3 is 12M. And 12 minus 8, basically, 0.12 minus 0.08 is 0.04 M. Now, oh, I'm sorry, I shouldn't have had M there. This is a constant of 12. So now we're going to divide both sides by 0.04. So 12 divided by 0.04 is 300 equals M. So basically what we are saying is that at 300 minutes, both plans cost the same. Does this seem logical? It sounds logical. So if we charged at 300 minutes, both plans are the same, and we can go back and check our work. So if we did that, let's plug in 300 for both sides. We have 15 plus 0.08 times 300, and we want to see if that equals 3 plus 0.12 times 300. Okay, 0.08 times 300 is 24. So 15 plus 24, does that equal 0.12 times 300? 3 plus 36. 15 plus 24 is 39, and 3 plus 36 is 39. So yes, they are both equal at 300 minutes. We are concluding this video. If you have any questions, please bring them to class tomorrow.